Okay, let's find the remaining sides and angles, if possible, of the given described triangle. Okay, so let's find beta first. Notice I have two angles that are missing, so I'm going to have to check to see if there is an extra triangle. Okay, we could end up with two possible triangles. Okay, so first things first, let's find beta. I'm going to go ahead and call it beta 1, which makes this gamma 1 and C1. Okay, my first possible triangle. Okay, and so to find that, I will use sine of beta 1 technically over b, which is 23.5, equals sine of alpha, 42 degrees, over a. I'm going to multiply both sides by 23.5. And then I'm going to use the inverse sine, or arc sine, function on my calculator. And you want to avoid typing it in the calculator as long as you can, because it'll help you maintain accuracy. Okay, so inverse sine, 23.5 times sine of 42 degrees over 17, close my parentheses, I get 67.6, no, I just do one decimal, 67.7, let's go 67.7. Okay, so that's going to be beta 1. Now, let me go down here and write out beta 2. Remember, that's 180 degrees minus 67.7 degrees. And that gives me 112.3. Okay, I'm going to keep that in mind for later. All right, let's go back now and finish this problem. So if beta is 67.7 degrees, then alpha can be found, gamma can be found by subtracting from 180, 42 degrees, which is alpha, and beta, that is beta 1, 67.7, that gives me 70.3. Okay, so 42 degrees plus 67.7 degrees plus 70.3 degrees is 180. Okay, so that's going to give me gamma. To find C1, I'm going to use the law of sines. Use A and alpha. Multiplying both sides by sine of 70.3 degrees. Type that in the calculator. And that gives me 23.92. Okay, so that's one possible triangle. Okay, so now, we did say a moment ago that beta could potentially be 112.3 degrees. Well, let's make sure that's a feasible answer. Okay, is that possible? Well, alpha is 42 degrees, beta 2 is 112.3 degrees. If I add those together, I get 154.3, which is less than 180. Okay, so as long as that's less than 180 degrees, this is a possible triangle. Okay, great. Let me go and fill in the rest of this. So alpha is 42. A is 17. Forgot how to write 17 there. Okay, beta is 112.3 degrees. B is 23.5. And now that's going to change what gamma could be and what C could be. Okay, so you see how this is a new problem. All right, so let's work it out. If, let's see, there we go. So to find gamma, okay, if beta, although it's beta 2 now, were 112 degrees, I would subtract 180 degrees minus 42 degrees minus 112.3 degrees. And that comes out to 25.7 degrees, so that's going to be gamma, 25.7 degrees. And if that's gamma, I can find C2 using the law of sines and that now known gamma. Okay. Multiply both sides by sine of 25.7 degrees. And then I type that in my calculator. So sine 25.7 times 17 over sine of 42. Whoops. 42, close parentheses. And that gives me 11.02. 11.02. Okay, so there we go. In this case, let me go and make this red too so we can see that that was a found answer, solution. Okay, so those are the two different triangles that could give me the exact same described triangle. Okay, so that's a lot, but I think we can handle it.